Hey everyone, welcome to the second session of pair of linear equations. In the last session of pair of linear equations, we have learnt what are basic terminologies used in this concept, and we have also learnt what are intersecting lines. And now in this session we are going to learn about coincident pair of linear equations. The word coincident came from coincidence, and meaning of coincidence is it is a condition that similar things happening at the same point of time. So why this term coincident used for pair of linear equations? Let's understand this using an example. Let's take one linear equation, say 3x plus 4y equals to 6, and we will draw a straight line for this linear equation on the graph, and we know how to do it. We have learned that in the last session. So we require minimum two sets of values for x and y, and those values should satisfy this equation. That is, if I put on the left hand side, I should get the right hand side value. So let's start with value of x as 2, so it has to be multiplied by 3 because it is 3x, so 3 2s are 6. Then y has to be 0, so that I'll get right hand side as 6. So I got the first set of values for x and y, that is x is 2, y is 0. So let's find second set of values. Let's take this time negative 2 for x, so it will be 3 into minus 2, that is minus 6. Then y has to be 3, so that I'll get 6. So I got value for x as minus 2 and y is 3. So now we have two sets of values for x and y for the equation 3x plus 4y equals to 6. So let's plot these points on the graph and get the straight line for this equation. Our equation is 3x plus 4y equals to 6, and the first set of values for x and y is x is 2, y is 0. Since y is 0, the point lies on x-axis. And the second set of x and y, x is minus 2 on the negative side of the x-axis and y is 3. The point is over here. So let's join them. We are getting a straight line for the equation 3x plus 4y equals to 6, since it is a linear equation. Let's take one more equation, 6x plus 8y equals to 12. We'll repeat the same process which we have done for this part. We have to get minimum two sets of values for x and y so that we can draw a line on the graph. And those values has to satisfy this equation. That is, if I put on the left hand side, I should get right hand side value as 12. So let's start with any random value. Let's say x is 0, then 6 is multiplied with 0 since it is 6x. Then y has to be 1.5, so that I'll get 12 on the right hand side. So the first set of values for x and y is x is 0 and y is 1.5. Now let's go for second set. This time let's take value of x as 6, so it is multiplied with 6. 6 into 6, 36. Then y has to be minus 3, so that right hand side becomes 12. So my second set of values for this equation is x is 6 and y is minus 3. So let's use these 2 points for drawing a graph for the equation 6x plus 8y equals to 12. Here is the graph. Here you can see there is already a line for the equation 3x plus 4y equals to 6. Now we have to draw a line for 6x plus 8y equals to 12. So here is the first set of values for x and y. X is 0, y is 1.5. Since x is 0, this point lies on y-axis at 1.5. The second set is x is 6, y is minus 3. So x is 6, y is minus 3, that is on negative side of y-axis. The point is over here. Now let's join these 2 points. We have got a straight line for the equation 6x plus 8y equals to 12. Now you can see that these 2 equations are giving the same line. We should have got 2 different lines for different equations, but here the 2 lines are merged and we got the same line for both the equations. Such linear equations are called as coincident linear equations. In such situations, all the points on the lines are common to each other, and these common points we cannot count since there are infinite number of common points. And you must know that common points are solutions. So we can say that we have infinite number of solutions. So in conclusion, we can say that in case of coincident pair of linear equations, we get infinite number of solutions, that is infinite number of common points. And since we got solution for these 2 linear equations, we can say that these 2 linear equations are consistent linear equations. They are also called as dependent linear equation. So now let's understand why they are called as dependent pair of linear equations. We are having these two equations. Let's consider one by one to understand this concept. Let's start with equation number 1. Let's multiply this whole equation number 1 by 2 on both sides. We get 2 3s are 6x plus 2 4s are 8y equals to 12. This is nothing but equation number 2. They both are same. Now let's consider equation number 2 and let's divide this equation on both sides by 2. So this 2 divides both the terms. When it divides 6x, we get 3x. When it divides 8y, we get 4y. When 12 divided by 2, we get 6. This is same as equation number 1. Now we understand that if equation 1 is not there, we won't get equation number 2. That is same as this. And if equation 2 is not there, we won't get equation number 1. That is same as this. By this we understand that these two equations are dependent on each other. Therefore, they are called as dependent pair of linear equations. So in this session we have learnt
State Board is now available in pen drive and SD card format. Our quick revision chart book is also available in English and Marathi language. Click on the link to buy now. You may also check the description below. Thank you.